finish up lesson 4.9. Our first learning objective on the front side of our notes here is going to be, I can identify equations of perpendicular lines. Tell me, what are perpendicular lines? What makes lines perpendicular? Isaiah?
When they cross.
Okay, when they cross, when they intersect, and what else to be true? All they have to do is intersect to be perpendicular?
No.
What do we need to add to that, Carly?
They need to have 90 degrees.
Yeah, they need to form 90-degree angles. It's not all lines that intersect necessarily have 90-degree angles, but when you want to talk about perpendicular lines, they do have to intersect, and they have to form 90-degree angles around that point of intersection. Ricky?
Okay, well I thought perpendicular lines were when they just touch each other.
Well, and when they intersect, aren't they touching each other?
Right.
But they can also extend beyond that touch. They do not have to just stop there at that other line. They can go through it and intersect through it. Ricky?
What if it's like touching like this, but then on the other side it goes like up or down?
Okay, well here's the deal. If when they intersect, one right angle is formed, the other three automatically be around that intersection become right angles. Okay, you can just, that's something you'll learn in geometry next year, or probably even should have learned before you got to here. Okay? So when we have non-vertical lines that are perpendicular, they're going to be perpendicular if and only if the product of their slopes is -1. Because I need a pen. -1. What does product mean? Product of their slopes. Product?
Multiplication.
When you multiply, the result better be. Okay, so the product of, so when you multiply the slope of a line and another line, when you multiply their slopes, it's that product should turn out to be -1. If it does, then you can say you have perpendicular lines. Okay? Notice it doesn't say anything about the y-intercept. It just says the product of their slopes has to be -1. Vertical lines are perpendicular to what type of lines do you suppose? By a vertical line, Morgan? Okay, a horizontal line. Yeah, they're gonna cross to make right angles. So vertical lines are automatically going to be perpendicular to a horizontal line. All we have to do is say, you know what, this is a horizontal line, that one's a vertical line. I know that they would be perpendicular to each other on a graph. So tell me something about the product of a number and its reciprocal. If I ask you for the reciprocal of 2, what's its reciprocal? What's the reciprocal of 2?
2 over 1.
-2.
No, I'm not sure I heard it yet.
1 over 2.
1/2.
Oh.
Yeah, 1 over 2. 1/2 is the reciprocal of 2. What's the product of 2 and 1/2? In other words, if you take 2 times 1/2, what do you get? 1. Okay? So the product of a number and its reciprocal is 1. But for us to be able to prove that lines are perpendicular, their product has to be
-1.
-1. So what we're going to do then is we're going to say, well, therefore, if we take the product of a number and the opposite of its reciprocal, and so in other words, instead of just multiplying by the reciprocal, if you multiply by the opposite of the reciprocal, then you should get a -1. So here's an example I have here. Here's a number times its reciprocal, and notice we get +1. 1/4 times 4 over 1, they're reciprocals of each other, and you get 1. If we take 1/4 times the opposite of its reciprocal, so a -4 over 1, what do we end up with? What's a positive times a negative? Negative. Now let's just multiply across upstairs. 1 times 4, 4. 4 times 1, 4. We do end up with a -1. So notice, now we didn't take a number times its reciprocal. We took a number times the opposite. Think of it as one has to be positive and the other has to be negative. In reciprocals, when the number and its reciprocal, they both have to be the same sign. So over here, when they're reciprocals of each other, they're both positives. If you have a -1/3, what's its reciprocal? What's the reciprocal of a -1/3?
1/3.
-3 over 1. It too has to be negative. So we have to think of it though, wait a minute, we don't want it to multiply to be +1 though, so we're not going to do that. We're going to take the opposite of that reciprocal so that we can get a -1 in the end. So let's just do number 5 here. Here's what you have to do today. There was nothing in the standards that said it has to have the same y-intercept, different y-intercept, didn't say anything about the y-intercept. The only thing it said is that the product of the slopes have to be what? -1. So we're only going to have to identify the slopes and then show that they would multiply together, give us a -1. So what's the slope of our first line there?
2/3.
2/3, okay. What's the slope of that next one?
-3/2.
-3/2. Okay. You know what? They kind of look like they could possibly be, let's check it out. They kind of look like they possibly could be perpendicular lines. 2/3 times -3/2. Product of their slopes has to be -1. What's a positive times a negative?
Negative.
Negative. And what would happen if I did some simplifying before I multiplied? I'd have 3 goes into itself once, up and down. 2 goes into itself, up once and down. So what do we end up with? Yeah, -1. So we do end up with a slope of, or a product of their slopes being -1. So we already could say those two at least are perpendicular, but before we do that, we're going to make sure there aren't any others that can join in that group. How about y equals -1? What did I just talk about while we were correcting? When the x is missing, what kind of a line do we have, Morgan? We have a horizontal line. So that's what we would identify. We would say, oh, this is a horizontal line. Because it's not going to do us any good to identify its slope because the slope is 0. Are you going to be able to take anything times 0 and get a -1? No. But yet, is there a line that is perpendicular to a horizontal line? What kind?
Vertical.
Vertical line. Okay, let's see. What's our next one? X equals 3. What kind of line is that? That's a vertical. Because what's missing? What did I say would be missing for a vertical line? The y. So this is a vertical line. So all we have to do is identify that it is. We say, oh, that one's a vertical line. And we learned that a horizontal line is perpendicular to a vertical line. It has to be. And so we're going to say that we have 2 sets of perpendicular lines. The first set is 2/3 x subtract 4, and y equals -3/2 x plus 2. And perpendicular is a long word, so we're going to use the math symbol for it right away. Isaiah?
Isn't it like half of a plus sign when you ever have a
Yeah.
plus sign?
It's like an upside down capital T. Yeah, part of a plus sign. It's an upside down, I could just say it's an upside down capital T. That's the math symbol for perpendicular. So why don't we just use it? It's a lot shorter than that word perpendicular. Okay, and then we said that, you know what? One of these is a horizontal line and the other one is a vertical line. So they too would be perpendicular. And there's our support above for it. We identified the slopes when they weren't horizontal and vertical. Show that if you multiply their slopes together, you do get a -1. The other case, we didn't have to worry about their slopes. We said, you know what, this one's a horizontal. We identified that. The other one's vertical. That tells me they are perpendicular. So there's our answer and our support above for it. Now, why am I being such a stickler about this? Because you know what? I don't want you just writing it down and not even showing yourself later on when you look at it. Why did I say those are perpendicular? Okay. Anybody have questions on that one? Okay. I would actually rather work with perpendicular lines, and here's the reason why. Because if the equation is given to you in slope-intercept form or point-slope form, you don't have to work any harder. You can pick the slope right out of them, because that's all we need, don't we?
Mm-hmm.
So, in the first one, what's the slope?
-3/7.
-3/7. What is x being multiplied by? It's in slope-intercept form. We know that whatever's in front of x is our slope. What's the slope of the next one?
-7.
-7. That one is in what form? Point-slope form, but we don't need to rearrange it because we could care less about the y-intercept today. We only care about the slope today. How about the next one?
1/7.
1/7 is the slope of that one. And the last one? 7/3. Okay. So do we have any perpendicular lines here?
Yep, 2.
Okay, Isaiah, what's maybe one?
I'm thinking that the y equals -3/7 x minus 4 and y equals -7. Y minus 7 equals 7/3 x minus 3.
Okay, so you're saying these two right here. So let's show that -3/7 has to multiply times the 7/3, and it has to come out to what? -1. Negative times a positive? Negative. A number times its reciprocal? 1, yeah. So we end up with -1. So we're going to say yes, there's our first group of perpendicular lines. And the other one is written in point slope form, so a little bit longer. Do we have any other thing? Which one?
The other 2.
The other two you think might be the two we haven't used yet?
Yeah.
Let's check it out. So we're going to do -7 times 1/7. A negative times a positive. Negative times a positive. Negative is 7 the reciprocal of 1/7, or vice versa, is 1/7 the reciprocal of 7.
Yeah.
So, you know what? I would say those two are also perpendicular to each other, not to those other guys, but to each other. And the middle, the third one. So they have to basically, when you look at the slopes, one has to be positive, the other has to be negative, and they have to be reciprocal to each other with other signs. So again, we only have to worry about the slope today, or if they're horizontal and vertical lines. So any questions about being able to do our first objective, being able to identify equations of perpendicular lines? Okay, when we go to the back side, we're going to meet our other objective, which says I can write the equation of a line perpendicular to a given line. Well, this sounds like yesterday, but yesterday was parallel. To a given line passing through a given point. So in other words, we have this line, we have this point that's not on the line. We're supposed to find the equation of the line that's going to cross through that point and be perpendicular to that given line. So what's going to have to be true for it to do that?
Slope has to be -1.
No, the product of their slopes has to be, right? So we're going to start thinking in terms of, you know what, I just got to make sure I make the slope of the given line, I use the reciprocal and make it its opposite for the other one. So here's our given line. What's its slope?
1.
1. That tells me, you know, right now I'm just going to make a rough sketch. I got a line rising from left to right. It has a positive 1 slope. Then I'm given this point over here. I have no idea. All I know is that it's just not on that line. I have to find the equation of the line that passes through that point that will be perpendicular to the given line. So I could just draw it right now because I know it has to make right angles. So I'm looking for the equation of that dashed line I just drew. What kind of a slope does it have to have right now for sure?
-1.
Negative. No, it doesn't have to have a -1 slope. It has to have a negative slope. Because the other one has a positive slope. And whatever I find that negative slope to be, when I take it times that other one's positive slope, it has to multiply to be a -1. So what is the reciprocal of 1? 1. 1's the only number that it's its own reciprocal. And the opposite of 1 is -1. So the slope of our new line, our perpendicular line, has to be -1.
Oh,
Is 1 times -1, -1.
yes.
Okay, then we're good to go.
Question.
Yes, Ricky?
So does that mean we're already done?
No.
No?
Because here's what the directions say, just like they did yesterday. Write an equation in slope-intercept form,
Oh.
perpendicular to the given line, passing through the given point. So what did we do yesterday? We called this x sub 1, y sub 1, and we used point slope form. Yes?
So then we'd have to use both slopes, like both lines, or just?
Nope, just this one. This one only already has its own equation. Here it is.
Okay.
Okay? We're finding the other equation.
Just want to make sure.
So just like yesterday.
Minus 2.
So y take away what?
Minus
And
2.
then take away
2, okay, equals negative 1 times x minus
Negative.
negative 1.
Exactly.
So we'll change that to add the opposite before we do our distributive property. Change it, instead of subtracting negative 1, we'll add the opposite of negative 1, positive 1, and now we'll do distributive property. So we have y take away 2 equals what?
Negative 1.
Plus negative 1, yeah. Negative 1 times positive 1 is negative 1.
Plus.
Next step,
Plus 2.
Add 2.
add 2. And we're going to end up with y equals, it's going to be in slope-intercept form,
Negative 1.
negative 1x plus 1. Is that how we're going to see it in an answer bank though, Michaela? Yeah, they're going to clean that up. This is how they would show it in an answer bank. They're going to slip that one out of there and say, you don't need that, folks. It's just extra nuisance. Here's how we'll show you the answer in an answer bank. Okay? So here's our equation of our line that's perpendicular. So that's, right now I'm saying this is the equation of my blue line right here. It has a negative 1 slope. Well, that makes sense because we wanted a line that is falling from left to right. We don't care about the y-intercepts. Are they crossing the y-axis at the same place? No, but do they, by the way, do you think they can? Do you think they can intersect on the y-axis? Why not? Huh?
They won't touch each other.
Well, they will. They'll intersect. They can have the same y. They can have the same y-intercept. They don't have to, but they can. Okay, so that point where they intersect can be the y-intercept, or it can be some other point on the graph. We don't know where these two are going to intersect. So questions on that one?
No.
Okay, what do you think we have to do first in this next one?
Simplify the negative 10x plus 2y.
Well, not really simplify it. We have to. We got to get it in a
Slope intercept.
form that we can pick out the slope from, right? Yeah, it's not in any form right now. What form is that?
Standard.
Standard form. You can't tell what the slope is from standard form. So what's going to be our first move here? So we can, because we need the slope from this line. We have to have it. Add 10x to both sides, okay? So add 10x to both sides. We'll have 2y by itself now, 8 plus 10x. What's our next move?
What?
Ian?
9 by
Divide by 2. What gets divided by 2?
2. All of it.
All pieces, right? Yeah, all of the pieces get divided by 2. So we now have our y alone like we wanted, and the reason we wanted it alone is so we can get the slope from this line. Do you agree with me? 4 plus 5x?
Yeah.
Okay. We went through all that work for one reason. We need the slope, don't we? We need to know that this one has a slope of 5. Why is that important?
So then we can find something.
Yeah, you gotta find the slope for the other one. The other one's gotta be perpendicular to it. So what, basically, let's do this in our notes. Let's say m equals 5 for the given line. I want everybody to write this in your notes. Why is this such a big deal? M equals 5 for the given line. We have to use that to help us decide what is m going to equal for the perpendicular line. That's our reason for doing it. We had to figure out what is the slope of the other one, so I now know what the slope of my new line has to be. What does it have to be?
4.
Negative what? not negative 5.
Need one.
Okay, negative 1/5. What's the reciprocal of 5? 1/5. What's the opposite of 1/5? Negative 1/5. So we have to have a slope of negative 1/5 for our perpendicular line. Your brain's going to want to go to parallel. Yesterday we got to just use the same one. Today we have to think more. We have to say, hey, wait a minute, no. I have to find the reciprocal of that. And then I have to make it its opposite. So now I'm ready to do, x sub 1, y sub 1. So y take away 1, negative 3 equals, no, negative 1/5. We're working with our new line. X take away 4. Okay, get that? Solve for y. Do your magic. After you do your distributive property, it might be a good idea to look up, because some of us are not doing a good job with this step.
My problem is like when you subtract a whole number from fraction. That's
Yeah.
what
So here's what we're going to do. We're going to rename this. We can see that we're going to have to subtract a whole number from a fraction, so we're going to make that whole number into a fraction with the same denominator. What name can we give 3 that has the same denominator as that? Sam?
3 15.
How much?
Oh, 5 15ths.
How much?
5/5.
15 over 5. It's got to divide out to be 3. So there's so basically what do we have to take times 3 to get 15? Or to get, excuse me, what do we have to do to that? What do we have to multiply it by to get it into fifths? We're going to take 1 times 5 downstairs to get fifths, so then we got to do that upstairs, and that's how we get our 15 fifths. Okay, now it's going to be easier to work with without a calculator. And so I'm now going to do what to both sides? What next?
Subtract 15 over 5.
Subtract that 15 fifths. When you're subtracting fractions with the same denominator, you just work with their numerators and keep the denominator. What's 4 take away 15?
-11.
Negative or positive?
Negative.
Negative 11 fifths. So we have our negative 1/5 x plus negative 11 fifths. That's what the right side is.
So can you just write -1?
Yep, so let's just clean that up and make it y equals negative 1/5 x minus 11 fifths. What's another name you might see in an answer bank for 11 fifths? 2 and 1/5. What's another name you might see? What's 1/5 as a decimal?
2.1.
Yeah, not 2.5, 2.2, yeah, just 2.2. Okay, so here's our equation of our line. That should be perpendicular to the given line that we didn't ever draw. It had a positive slope. It's going through some point. We just found the equation of the line that goes through that point that creates that perpendicular line. That's the equation of that dashed line. Okay? So these are the 2 things you're doing in the homework. You have the notes now to show you what kind of work to support your answers so you can get it completed to the standard it should be. And it isn't like you have 100 problems to do. You should be able to do what is expected for the ones you do have, though, right? Anybody have questions? Okay, then let's get to work.